Welcome back, everyone, to Merge Conflict, your weekly developer podcast where I right-click picture-in-picture and I shove Frank Krueger on my monitor over here. How's it going, buddy?
Very good, very good. I like being on the little monitor through the two-way mirror that's sometimes called a one-way mirror. Hi, I'm coming to you through a mirror.
And we're going to see if my camera continues to work today and doesn't freeze up. I had to replace myself before, although now it seems to be flickering. So I don't know what's happening.
AI? How'd you do it? Did you use one of those like image to video things? That would be kind of hilarious.
I guess I'm using Camera Hub because you said I look better when Camera Hub processes my video, and then when what's this other app that I have? Wavelink processes my audio and makes me sound better. Basically, you're saying just let all of the software AI overlords process this, and then it's not actually me. Still in a garage, but here.
We'll never get you out of that garage. Well, it's funny, like in my endeavors to use more and more local models, I've actually been playing around with the current text-to-speech models, which is, text-to-speech has been good for a decade now, but like they've gotten really good. And so I was trying some of the open source ones and just seeing how really good they are. Turns out, James, they're really, really good now. And to the point where you can actually fingerprint people too. So it's not this episode, I promise all of you, but it would be fun to at least put in like a 5-minute stub somewhere with synthetic James and yelling at synthetic Frank and find out if anyone notices a difference. You will, because you won't hear my giggling. I probably won't giggle as much with the AI.
I did watch I believe it's a Morning Brew video, I want to say, where the gentleman went to a few of the leading avatar companies where they will scan your face and they will create an AI representation of you, and then they'll do voice models on you. And he did a professional one. Okay. More seems to be used in like training videos, for example, where they'll have a person and then they can have them talk and go through training videos. So he tried that, and while that was processing, he said, okay, let me just find the top tier online, whatever avatar and top tier video or audio voice spoofer. And what they did is they did some trials. I'll find a link to this and put it in the show notes. But basically what he did was he said, okay, first let me see if I can spoof my coworkers on a Zoom call. So
sure.
This one was quite complicated because what they ended up having to do was, and then what he also did was once he put it in there, he let his friend. So the idea was to not even have you be the person presenting. It could be somebody else spoofing you.
See, now it's a lie. I didn't mind it when it was him typing something, but if you're not even typing in the responses, now it's bad. But okay.
Well, fine. the idea was like, okay, if you can do voice in this, can I, do this? But the problem with the software, at least for this, was it wasn't real time. It was only pre-recorded, so you had to render out the video and things like that. So they said, okay, they worked with their manager, and it was for a piece. So they said, okay, we're gonna ask me a question. I'm gonna pre-record and see if I can spoof my coworkers. And they even had like a looping like head nod, cool. Like and there's an OBS playing it back. And they definitely spoofed some of the people that maybe weren't paying as close attention. And then other people they definitely spoofed. But then they did this other one, which was they did a FaceTime call with his parents and did a thing where they're like, hey, how's it going? And did this, blah, blah. And they just pointed the webcam or the camera at the computer, audio, video to play it back. And his mom right away was like, something is wrong. This is not, she knew right away.
Yeah.
And then his dad didn't notice anything at all. Like and it was the same exact clip. It was like the same exact clip, the same exact thing. Yeah. And then they did one more, which was with the professional spoofer thing where they rendered out a whole video and it was, you could just tell it was like completely AI generated. So I mean,
okay.
It's mostly because it's procedural audio talking, right? It's lip syncing, do all this stuff in real time. If you go in and you're doing motion capture, that's real motion capture, and then it's usually animation CG on top of it. And even if they are doing other stuff, it's quite complex to deep fake for long periods of time that looks pixel perfect accurate. But it was kind of fascinating in general just to watch it. But it gets me thinking, Frank Krueger, about
Hmm.
thinking.
Oh,
Uh,
hi. Are you a
and
philosopher now?
no, about LLM thinking. Recently in the last year or so, models have evolved, and you often now see in the CLI in VS Code, you go and you pick a model, and then you have this thing called effort, sometimes called thinking effort, reasoning effort, thinking level, whatever.
Yeah.
And there's a default, and I just pick
Extra
said
high.
default. No, just default. Whatever the
Nope.
default
Okay.
is,
Okay.
that's what I pick. It's
Auto model
usually
default thinking.
default thinking. Yeah, auto model, default thinking. I guess in auto, it does you don't even get to pick the thinking level. But the thinking level, I never really understood it. I guess I understand that it's a level of thinking of some process. But
Is
I
it?
figured in my mind that there are very smart people that picked a default for a reason. So I never really changed it. However, a lot of people have been asking me about it. So I figured we have a conversation about
Ah.
thinking, reasoning, effort, thingy, what it is, why or why you shouldn't care about it, and what it's actually doing under the hood, and what's Frank doing today in his coding.
Yeah, it's a good topic. I don't think either of us are model experts in this area. I'm a model expert, I think, when it comes to building and constructing AIs, but tuning them, this is a tuning thing. This is a quality of response thing. This is machine learning, but even weirder machine learning because it's weird, right? Like, we had this idea that if you ask the AI to plan ahead, it does better. And that's because it gets to uh, first take like a high level approach to the problem and then get into the nitty gritty of it. And I think that that manual process of planning was recognized by a lot of the ML experts out there. And so they decided to basically bake that into the training of the model, where no matter what you told it,
Mhm.
it would start thinking first. And thinking is basically planning. I mean, they're really not too different, other than planning is a mode that we humans tell the agent to go into, whereas thinking is kind of baked into their training, where whenever given a problem to solve, they know to first output thinking tokens and to kind of try to, well, it's hard to use these words, but try to work out the problem at a high level before it dives into the nitty gritty. And I think it's been mostly okay-ish good. It's definitely quicker for us to just say solve a problem than it is to go into plan mode, ask it to think high level, then slowly whittle it down to a thing. I think it's nice that it's a little bit automatic. What's your gut feel for the thinking?
Well, it's hard because I'm often demoing, and the more
Hmm.
things are
It's rough.
thinking, the
Yeah.
longer it will take. A good example of something that is not thinking is maybe older GPT models, or I believe Haiku doesn't think.
Hmm.
I don't,
Okay.
I mean, at least there's not a thinking level that you can set. Maybe there is thinking associated with it, but my understanding is there's thinking models and non thinking models. So,
Yeah.
GPT was extremely quick, and Haiku is
Yeah.
also extremely quick. I have never changed the setting because I really don't know. That being said,
Yeah.
how you talk about it does make some sense. If I get a really hard problem, let's say mathematical problem or house construction problem, I inherently go into a deep thinking mode. If I have to flip a switch on or off, or I need to set up the podcast, flip the switch, there's no thinking. I just do it, right? And here I breathe inherently. There's no thinking that's happening. It just goes. If I'm setting up for the podcast, there's a fairly low level of thinking that is involved. It's turning on lights, it's checking the software, I'm thinking about the microphone placement, the U placement, the topic, XYZ. If I'm doing research for the podcast, then I guess I go a little bit deeper. So I guess if I start to think about
Yeah, it's hard.
thinking,
Huh? Yeah.
you know, if I start to reason about no, if I start to correlate thinking to planning or researching before executing said plan, which would be like executing this podcast, then that resonates a little bit more with me. Because one, if I am doing and performing deeper levels of setup, of thinking, of research, then that takes longer. And I am burning more
calories.
Calories. Tokens. I have more processing units of my brain. Or my brain is more focused, and more processing is happening towards that equation.
Yeah. I don't like to anthropomorphize too much, though. These things don't work the way the human brain works. We need to be clear about that. In fact, thinking is a solution because of the big flaw in how LLMs work. And that is they generate one token at a time based upon the current context and what it's already output. Its history of what's already been seen. It's outputting the next token, the next token, the next token. So if it's doing that in a serial fashion, outputting tokens, like go write this line of code, by definition, it has no idea what the end product is going to be. What is the last thing it's going to change the code to, or what are the final lines? What is the net effect of all these lines? And so the thinking mode gives it that opportunity to outline the problem and state, like, from the beginning, okay, I'm going to edit this file, then I'll change this icon, and then I'll change this path, and then I'll recompile the thing. That's its thinking stage. Now, when it goes to output the real first token, as in generate a line of code, it already has that outline to work from. It's in the history. So we're working around this basically flaw in how LLMs work, in that they're one token at a time based purely on their history. They have no advanced thought, no forethought. While I'm speaking, my brain's racing a tiny bit ahead. And again, I shouldn't be anthropomorphizing, but my brain's getting a little bit ahead of my words. And that's why sometimes I'll stumble when I'm talking, because my brain's going a little bit faster. Humans can do that. We're advanced. We can think faster than we can speak. AIs can't. They think and speak at the exact same rate. So in order to do something intelligent or that requires future context, they need to write that future context first. And that's the thinking mode. But I do want to comment on your fast versus slow. Like, it's real, man. It's real. Like, there have been so many advances in the execution of neural networks to make them faster and to make per token CPU cost or GPU cost, whatever, processing cost lower. And we really worked hard on it. We made big context work. And then we added the stupid thinking mode that has basically 10x the amount of tokens that we need to output. I don't know about you, but if you ever open up the thinking window and you see it basically solves the whole problem in a serial fashion. But that was just thinking. So now it has to come back out and rewrite the thing in a serial fashion a second time. And it's just painful sometimes, especially with the slower models, where you see it write out this 300 lines of code. And then you're like, oh, great. But that was all in the thinking buffer. Now I got to wait for it to write out those 300 lines of code in the real buffer. It's super frustrating when the thinking isn't actually doing what it's supposed to be doing, working at a higher level, working on an outline, thinking of the future. But really, it's just working in that serial fashion. So it's a little bit annoying. We had all this effort to make neural networks more efficient, and then we just 10x the amount of work that they actually have to do. For sometimes no benefits, other times huge benefits, sometimes really bad benefits, especially if it gets into a circular thinking loop. I don't know if you've ever seen this, but I think I'm going to do it this way. But wait, what if this? But wait, what about that? Oh, I'll go back to A. A's good, but what about this? And you're like, oh my God, just break out of the loop and write some code. I've done the steering thing. I'm like, just stop thinking and write some stupid code. You've been thinking for 30 minutes. Write code.
Yeah. No, it's true. It's the fear I've always had about changing anything from the default is for that exact reason. Is that I never knew technically how it works, and if I was going to get it into the correct state in which a higher or lower thinking and reasoning level would be appropriate. I mean, I guess if we're talking about what developers should think about is not just how it works and how it's reading and writing and processing, but there's going to be this decision that is very visible to them. It already is. And I have talked to a lot of developers that seem to say, well, I'm just going to pick the biggest context, the biggest
Yep.
model,
Heck yeah.
and the most reasoning, because why wouldn't
Mhm.
I?
Yeah.
Because that's the best.
Yeah. It's such the wrong mentality. Yeah, it's the bigger is better. Bigger is always better, you know? Ford F-150, good. 350, it's almost 3 times better. You know, it's like 2 point something better. Yeah, you think that, right? Oh god, I hate that word now. Um, but
Sorry.
I would say it's just not true. The hardest part is we don't know when it's true because sometimes thinking helps for sure. It's that scenario that I was talking about when it needs to come up with a whole plan before it starts executing. But I would argue it's probably better to work out a plan first than to rely on thinking. Thinking is kind of the autopilot thing where you're like, I'm going to give you 2 sentences and I want you to one shot um, Unreal Tournament. Give me the whole game in these 2 very vague sentences I wrote. In that case, thinking mode's probably good because you did not give it enough information and it's going to need to work out some details before it writes that first line of code. It's important. But other times, if you tell it, hey, there's an error on line 6, it's because there's a missing semicolon. You really don't need thinking. I promise you, you do not need thinking in that case. As you said, GPT-4 could solve that problem trivially, and you just don't need it. And the problem we have as developers is deciding. We don't know how these work. These are very sophisticated black boxes. We don't know. So, of course, Ford F350, always. You need that to go up and down the street at 30 miles an hour. 100%. Of course you do.
Yeah,
That's
why
the
wouldn't you?
problem.
Makes logistical sense to me. Uh, and there's a graph from Anthropic when they launched Opus 4.7, and they were talking about the token usage, and it seems as though they were optimizing token usage for lower reasoning thinking levels. However, they added a new extra high or max. There's max and there's extra high. I don't know. And
Yeah.
it goes off the charts. It's
Oh, does
wild.
it? I believe
Mhm.
that. I've seen it go in its loops. Yeah.
And it just goes and goes and goes because there's that. And I agree with you. I think your analogy of what problem are you trying to solve? What is the complexity of it? What is the prompt that you're giving it? Are you giving it planning or not? And there's that. So Pierce used to always say, a wise man, Pierce Bogan used to say, that he would plan with a larger model. So he would say, I want to plan, I want to get the details correct, ironed out, thought about. And then he would execute it with a smaller model
Yeah.
because it's just following very specific
Yeah.
instructions and what to do. And it would give him pretty good results quickly.
I agree. But there's other knobs to play with because what you want in that planning stage is creativity, basically, and the freedom for it to kind of think of the future and also the present and think through all the problems. So think through all the potential problems. That's where a big model helps. Creativity, and no one ever talks about this, but you can change the temperature setting. Remember, these are random processes. You can make them more or less random depending on your mood. No one ever does this because it's not exposed in our UIs, but you can make it more random. Um, Give it a prompt to plan and have it plan 4 different ways with a very high random temperature, and you're going to get 4 different plans. And then, yeah, I agree with Pierce. If you have a sophisticated plan and you agree with it, give it to a simple model. Problem is, James, I don't know about you. I often don't read the plan. I'm
Yeah.
terrible. I'm like, plan this because I know planning's important, and because I know it's a way of thinking. It's a way of thinking through the problem because it'll still think during a plan too. Now we're at multiple levels of thought. Um, but then I don't read the plan. I'm just like, yeah, yeah, go, babe. I just know I wanted it to work it out before it started coding because that generally improves the results. So what I said about I agree with Pierce, but if I was a better developer, I would have it generate 4 different plans. I would read those 4 different plans, choose the best one, and then execute that. That's
Or
thought.
Or you would say, spin up 4 work trees, plan it 4 different ways, and then
Yeah.
implement all 4 of them, and then see them and test all 4 in action, and then
Yeah.
pick one based on the implementation that you like the best of the 4. Because,
See, I guess
why not?
that's where the problem that's my problem with the thought, like, because it's not like being more creative. By the way, creativity, our only knob on creativity is this random sampling. The
Mm,
more random you make the result, the more creative it's going to be. And I put that in scare quotes for people
yeah.
not watching. You should watch, by the way. It's on YouTube. Um, it, it's my biggest gripe with thinking is that it's one way to improve the quality of the results of these networks. It is not the only way. We've all learned now that harnesses and system prompts make a big deal. The tools available to the agent have a big impact on its quality. The ease of using those tools has a big impact on the quality. Planning has a big impact on quality. Thinking is like a cool little academic hack because they can bake that into the model. It can become a part of the training and they can post benchmarks saying, look, it thinks with this efficiency and all that. But that's just one of many knobs that we can turn to improve the quality of the LLM output.
Yeah. I recently was using, talking about system prompts and how the harness works. I was recently using GitHub Copilot for Xcode. I was working
Okay.
on a
Yeah.
Swift app, and they've had tons of updates. And first and foremost, they updated it to use the built-in Xcode MCP tools. So in
Yeah.
Xcode now, you can say expose the Xcode MCP, and coding agents can connect to it. Makes it 1,000 times better. Like it basically just gives it
We need
access
to
to
do a whole
Xcode.
episode on that because yeah, it brings up a lot of things. But yeah.
It brings up a lot. Well, it brings up the extensive. Why is Xcode just not as extensible? So you know what I mean. So,
Well, it also brings up why does Apple get to turn their apps into MCP servers, but they don't have a way for normal apps to become MCP servers? It
ooh,
brings up
spicy,
that's the question I care about.
spicy.
Why do you get to be special, Apple?
Uh, well, it's their operating system. They do what they
Yeah,
want. So
yeah.
I digress. But what I noticed was that there is only two. I think there's only 2 modes. It is just ask an agent, and there was no plan mode. You can, of course, add a custom
Hmm.
planning mode. However, what I realized is at least that team, and now this might change because I know they're evolving the product pretty quick, but this was at least 2 weeks ago, is when I would give it a prompt, it would, as part of the system prompt, tell it to create a plan, ask me about it, and then execute on it.
Oh, good.
So,
Okay.
and you
Yeah.
and you would see a UI for a plan in place. And inherently, that's what's happening. The to-do list, you see the to-do list. It has
Yeah.
come up with a plan of sorts. However, I enjoyed this because I could see the plan ahead of time, and it was asking me naturally questions for it. And it seemed to do that for every single prompt, no matter how complex it was. It was like, come up with a plan for this. And
Yeah.
to some extent, that is kind of good for our friend, the context window and cache tokens and having it all right there in some way.
Yeah.
Because I think that all the tool call, I don't think they were changing the system prompt. I don't think they were changing the
Right.
tools. The system prompt was come up with a plan first, then ask questions, then execute the plan when all questions are sufficed.
I really appreciate that in a harness because honestly, I'm sometimes so lazy I can't even click to change the mode to plan, or I can't remember the key binding to switch the
Yeah.
mode to plan, and therefore I won't plan. And also sometimes I'm like, God, no matter what it's going to have three questions. I could ask it to write a lunar lander, or I could ask it to write a script that says "Hello World," and it's still going to come up with three questions. It's going to ask me like, who baked in this 3-question thing? Anyway, I digress because I agree with you. One of my personal criticisms of a lot of harnesses is that when you switch out of plan mode, it kills your cache. That doesn't matter if networks are free to you, but it matters a lot if you're paying for requests, because cached tokens are far, far, far cheaper than input tokens, usually like a 10x multiplier on that. And money matters. So yeah, I really appreciate that happens. And it makes perfect sense because it's just another system prompt you're injecting. You're like, here's 30 tools you can use, but don't you dare call any of them right now. And,
Yeah.
the harness can make it even better. If it tries to call one of those tools during this pseudo plan mode, then it can just say, hey, buddy, not allowed. Stop it. Without messing with the system prompt. There's so much progress harnesses can make over all this.
I'm getting ready for a world, and I've never seen this yet. And if there is a harness that does this, please write in, leave us show note comments. I'm already living in that auto model world, right? And
Yeah.
I'm already living in the whatever the thinking token, the thinking level is just default to it. But it would also be rad just to have an auto agent mode. Like you just figure out what I want to do and you do it. Now, technically I could be like,
my mind mode.
I'm asking you a question. No need to change code, right? And then it will just do it. But figure it out ahead of time in one system prompt. So I just open it. It's one chat. It's like, I'll figure it out. You know what I mean? I'll figure it out.
The next time it prompts you for a question, have an LLM answer the question for it.
Yeah. Figure it out.
Read the plan up till now. Yeah.
Well, we've been talking about different pricing changes. This episode's going to go out, I think, on usage-based billing day. So,
oh no,
timely.
The apocalypse.
June 1st. So, one thing for developers, there's a lot of knobs to turn when balancing the models that they're using. And one is the model. The other is the context window and thinking about the cache and the cache tokens. The other things is the plan mode and creating the plan ahead of time. But the other one is this thinking level. So would you recommend developers play more actively with this thinking, effort, reasoning levels? When you do turn it up, it does say this may increase costs. Do they then turn it down in some scenarios to do stuff? What are your thoughts?
It's tough. It's a tough, because I do have an answer, and I'll give an answer, I promise. But first, I want to hedge my answer before I even give it. It depends. That's the problem. Like sometimes you need a lot of thought. Sometimes you don't need a lot of thought. It's really hard to predict. And the other big part is it's hard to A/B test these things because they're random samples of a random number generator. Like you can give it the same exact context and same exact code base, and it's going to give you two different answers, and they're going to be so similar to each other, but they're going to be slightly different. And maybe on the first run, they're not going to be so different, but maybe 6 chats down, they're going to be very different because they on each step, they're going to diverge a little bit more from each other. So it's really hard to A/B test these things. Should I have done this or not? But I'll give you an answer because I promised to. You should absolutely try low thinking mode. 100 million %. And you should do planning more because planning is just a manual way to say thinking mode. And it's a manual way that gives you a chance to interject a little because it will ask you 3 questions and you'll get to answer those 3 questions. And whenever it asks you 3 questions, that's your chance to just put in any old garbage, by the way. Just because it asks you what color is the sky doesn't mean you have to answer what color is the sky. This thing is a slave. It's a robot. You can put in the works of Shakespeare into that answer field to change how it's going to behave because it's going to read your response and it's going to act on it. So 100% you should try the lower thinking modes, especially now that we're in the pay per token world. 100 million %. That said, will you be able to tell? Like, what if it gives you a bad result? You're going to be like, darn you, Frank, you told me low thinking and
Yeah.
it
Yeah,
wrote bad
Frank.
codes. This is Frank's fault? Well, you can't prove it because I already said you can't A/B test these things. It's too difficult, and so you can't prove it's my fault, and therefore don't yell at me. Um, what would be a little bit fun is keep it on low or keep it on zero, and I'll get to. I'm trying out zero, by the way, no thinking. Um,
Hmm.
but try low, and you know what? If it writes some bad code, take that as a learning lesson, or you saved a bunch of money on not having thinking tokens. Maybe now you can go back to a snapshot. Go up one level in the chat, fork the conversation, and be like, all right, do some extra high thinking this time,
Hmm.
and see if it does better. Because honestly, the only way to get a feel for these things is to play with them a little bit. And we have to not be in this world where we think that there's for one prompt there's one answer. These are random number generators. They're gonna do random stuff. So you just got to try those different paths.
Yeah, there you go. Pro tips from the Frank
Yeah,
Kruger. I'm going to start to play around with it more and see.
yeah.
Although,
So
wouldn't it be nice to have an auto thinking toggle too?
there should be. There really should be. Like, there should be a tiny little network in the back being like, okay, that is a crazy request. You gave zero context to us. You did zero planning. Time to extra high the thinking. Um, so I just want to put out there. So I've been still enjoying rocking my Quen 3.6, 27 billion parameter model, which is tiny. Like, I think the new Grok that was just trained is like 1.0 or 1.5 trillion
Oh my
parameters. Like,
God. Wow.
yeah, and I'm rocking 27 billion over here. Quantized, 4-bit quantized. I don't know what Grok's running, but whatever. Um, so there's been an interesting study with especially this quantized version where it's a little dumber. Have you ever had a memory? You know you have the memory, but you just can't recall that memory. That's kind of what quantized is like with these smaller models. And people have found that turning off thinking is actually really beneficial.
Hmm.
Because you're running these things locally, you're burning a lot of compute and a lot of context on those thinking windows. And B, they don't seem to help too much with these quantized models.
Hmm.
This does not necessarily apply to Opus 4.7 extra high thinking. This applies to 27 billion parameter model running on my 3090. It actually benefits you and the model to some extent to not do any thinking, or at least that's what all the reports are saying. I have to admit, I haven't rocked this mode too much yet, but it's totally going to happen because I am tired of seeing it think in loops. I'm tired of seeing it write out all the code twice, once in the
Hmm.
thinking window, second time in the real window. It seems very wasteful. Instead, I'm going to do what I've been promoting this whole podcast is just make sure I do plan mode first and
Yeah.
then rock it out.
There you go. All right. We'll give it a try, folks. Let us know what you think if you're rocking all sorts of different thinking levels with your models, or what models you're also running locally or remotely. And let us know what you're thinking. Go to youtube.com/@mergeconflictfm. You can also go to mergeconflict.fm for all of your podcast needs. And you can subscribe. You can rate and review. You can send us an email. You can hit us up on Twitter. All of the links are at mergeconflict.fm. That's a little website. Boom. You just go there and things are there. All right, that's going to do it for this week's Merge Conflict. Have a great build, everyone. I'll be at Build Vibe Coding. If you're doing this here, we got a live code booth. We'll be on the GitHub YouTube where we have the terminal live, which is there's this whole terminal section there, like I guess in booth area or whatever, the booth area, a bunch of terminal stuff. And then we have a live code booth and we're going to be talking all the different amazing stuff from Build. So if you're interested in that, it'll be live streaming Tuesday and Wednesday, June 2nd and 3rd on the GitHub YouTube. So give that a look-sees and don't miss out. There's going to be a bunch of goodies. So head over to build.microsoft.com. You can register for Build for free. It's online.
Ooh.
You just watch it online. Just boom, you're there. You can
That's
also
gotta be the cheapest way.
That's the cheapest way. It's $0. $0. No thinking required. All right, that's going to do it for this week's Emerge Conflict. So until next time, I'm James Altamagno.
And I'm Frank Kruger. Thanks for watching and listening.
Peace.